Hello everyone. Good news. 5.0 gAirhawk software is published already. And now we briefly introduced gAirhawk software, the installation and workflow of data processing. Firstly, we take the app on the desktop. Double-click app, enter the setup. Here, the software remind to not install the software on the system disk and ensure that the disk space is greater than 30 GB. Okay, we follow the guideline. And we browsed their location. Program files here. It's okay. Install. It's fast to installation. Okay, finished. Okay. 5.0 gAirhawk is same as the last version. It supports 1K process and trajectory data and lidar data together processing in software. So the license should be copy and paste to the license folder. Open file location and check the license. There's no license, then we copy and paste license to this folder. Okay. Remove app, remove the license, and enter into gAirhawk software and check information. It's 5.0. And this is license information. It is temporary license, so it didn't show the device ID. If it is permanent license, they will show device ID. Device ID is lidar serial number. Okay, finished. Running gAirhawk software. And there are two issues. Please pay attention to. One is that there are improvements comparison with last version, such as reading folder, simplified coordinate system, point cloud optimized. Two issues is that the lidar unit should be updated latest firmware. In this way, 5.0 gAirhawk software could active or full function. Okay. We will take dataset. For example, after each flight, they will generate one folder like this. Just now we talked about the new firmware for your lidar scanning system. It means after updating firmware. There are 4 folders generated like this. After each flight, base, image, lidar, pause. Of course, if your lidar scanning system isn't updated latest firmware, no problem. You just create a new folder manually. So also it works. And please note that in base folder, their base data should transfer to this folder manually. You know, in lidar scanning system, they just collect post data, lidar data, and image data, but not base data. So after each flight, please transfer their base data to their base folder. For base data, when you transfer base data in base folder, please note that the software will read first file in default. Okay, we can take this data for example. Okay, we use the shuttle software, the tool manuals, GNS data decode, and we decode the raw data, cover raw data to Linux files, setting GPS, GLONASS, Galileo, BDS. Okay, covered. Okay, finished. And we check the data. Check this. We check base folder. There are 6 files in base folders. 1, 2, 3. Okay. And we back to software, gAirhawk software, and new project, and the same folder. Create a new project location, same folder of the raw data. Test, and then you can check the first file was read by default. In default, and we check the base folder. Yeah. In this way, the 1K process will be filled. So if there are more 2 files in base folders, please make sure the first file is raw data or Linux file. Is it raw data? This is Linux file. That's it. And we remove files and cancel. Then new project again. New project again, and here, the Linux file was ready, and in the folder, yes, the first file is Linux file. And this is image folder, Lidar folder, and the pass folder. Okay, we enter into gAirhawk interface. We can check the information. Oh, it is 5.0 version. And the license information. 5.0 gAirhawk is similar. It's same the 4.9 version. It processed trajectory and lidar data together. So the license should be required. Of course, if you do not use the license, you just processed lidar data, also it is okay. So you should not use the license. Okay. In this step, we should create new project. Previous, we talked about the reading folder, and here we do some explanation. When we create new folder and we saved this project in the same folder of the raw data, test, file name, test, whatever you like. And you can see the software read all the whole folders: base data, raw data, lidar files, image folder. Next, we talk about the new function, reading folders. And if we do not create new project in the same folder of raw data, the read folder function will fail. Okay, we can try. Okay, new project, and we save this project in the desktop. Then continue. So pump up dialog, manually input data. The base data is okay. Post data also is okay. There's no lidar data. It required input data manually. That's why we talk about the reading folder in the new function. Okay, we can see. Then come back and open the project. Okay, open project. Okay. In this step, it supports input coordinate. So we select input coordinate, and their base coordinate should be input manually. This is latitude, this is longitude, and this is elevation. Then we click OK. Then we will keep save this data. And in this data set, we use a ProMax coordinate system. Okay, so finished the data input. Next, we start setting coordinate system. In last version, we should set coordinate system according to local flight area, such as create new coordinate system. And select source episode WGS84 and projection central meridian, something like that. In 5.0 gAirhawk software, it supports WGS84 Gauss projection and WGS84 UTM projection. It means when you used WGS84 Gauss, you could select Gauss projection 3 degree or UTM projection. The output will be identified according to local longitude. Of course, the software supports customized coordinate system. The procedure is the same as last version, but customized coordinate system exclude WGS84 Gauss projection and UTM projection. That's it. It's faster and easier. That's why we talk about simplify setting coordinate system. Okay, we continue. And for parameters of this here Lidar, pause, output files, field of view, it means their laser sensors scanning degree. Normally, we recommend 55 degree to 125 degree for Livox AVIA sensors, and 24 degree to 135 degree for Hertz laser sensors. Distance, it means the detection range. Normally, we recommend 5 meters to 600 meters, but here we could set 200 meters. It is enough for short range and middle range. Intensity 0 to 255. Echo. Normally, we select multiple echo. It means more than 2 echoes. Filter duplicate points. If we select this check box, the point cloud is closer to real points. Pulse coordinate system support ENU and NED. ENU is in default. Output files. There are 2 moved by file and by strips. If we select by file, it means all the data will be processed, and how many Lidar files, then generate how many last file. Okay, we can check the files. Sorry. It means there are Lidar files, and it will generate line last file for final output. If by strip, it means the software only processed the strips you select. How many strips, how many last file generated. Okay, for this data, we select by strip. When you select by strip, their trajectory processed. First reading base data, then GNS kinematic differential, and trajectory pump up. Okay. Manually to select strip, 1 strip, 2 strip, third strip. And if you want to delete and reselect, we could select this area and delete strips and select again. One strip, two strip, and third strip. Whatever you select from left or from right, the strip you select will be adjusted according to flat times. In the beginning, the strips is the first, and landing area, closed landing area, it is the last strip. Okay, applied. Okay. Anyway, if we select by strip, the strip adjustment and cloud point optimize function will active. If we select by file, the strip adjustment cloud point optimized function will not active. And when we select cloud point optimized, the data process will take a little long time, and it requires high performance of PC system. And the main purpose of this chicken box is that their thickness of point cloud could reach to 2 or 3 centimeters. It improves the quality of point cloud and accuracy. Output color point cloud. If we select this chicken box, it means the output is color point cloud. Of course, the lidar scanning system must be building camera. And eliminate uncolored points. For this chicken box, for lidar scanning system, it collects lidar data and image data, and because of different field of view of camera and these sensors, so sometimes there are some points don't colored by image. So if we select this chicken box, the point cloud without colored will removed. File format. Normally, we recommend output by LAS file. Some clients want to output by TXT format. It's no problem. Just for customized requirement. Okay, we check sensors configure parameter, and this is GS100C model, and this is the parameter of the Lidar, and this is parameter of the camera. The Lidar scanning system is update one key processed firmware. Once input the data to the software, then software will read the parameters automatically. Okay, and now we start calculation. The trajectory will continue to process first GNSS and ANS integration, and output pass and reading pass file, and decode the photos. There are more than 200 or 300 photos, so it takes little time to decode the photos. Okay, finished decoding, photo decoding, and filter invalid data. The output is by strip. It means the landing area and turnaround area. The software do not process this data, so the software will filter invalid data and strip data pre-processing. There are 3 strips, so the same procedure will repeat 3 times. Filter invalid data. Strip data pre-processing. The last time filter invalid data. Oh, sorry. The data is from the 100C and with DVOX sensors, so the field of view should be 55 to 125 degrees. Sorry, make a mistake, but it doesn't reflect the data output. Okay, the first next file is processing. Oh, finished. Then we can click RK here. And now the point cloud display. And we hold the mouse, turn around the point cloud. And we hold the roller and drift the point cloud wherever you want. Forward, backward, zoom in, zoom out the point cloud. And second last file is under processing. Okay, we check the last file. Okay, first last file is output, and during this processing, the next file will store this folder, Lidar folder. After final processing, the last file will install. We sort out. We check. Just now, in this folder, there's no last file. And the GNSS result is output. And pause GNSS ANS integration also is output. You can view it. Maybe some client have question. The point cloud display is not clear. Yeah. The gAirhawk just displayed just displayed 0.1% of total point clouds. When finished output, we could take the last file to check in third-party post-processing software, and you could check clearly, such as Terrasonit, Cloud Compare, and Lidar 360, something like that. Okay, the second nice is finished, and the last file is under processing. By checking the Lidar data. First nice, second nice. This dataset is application for power line petrol, and we could see the structure. And this is the power line cable. Okay, the third The third line was finished, and the cloud point optimized active. Just wait a moment. It takes longer time to process. Okay, first, second, and the next file totally finished, and just wait for cloud point optimized. Also, comparison with last version, the progress bar is move on, so it means the software is working. Also, in tool menus, we also optimized cloud point cloud. If we use this optimized point cloud, the procedure is a little different. But this time we do not use this function. Maybe for this chicken box is better for processed data. Okay, calculation finished, and we click finished. Then we check the folders. Here you can see the next file disappear, and check here the final next files installed. We sort out its folders. Okay, so for the processed is finished, and it's easier and fast. Okay, so thank you for everyone.